my little data monkeys. This is the last video of my Python for Analytics series. Not sure if this is bad news actually. I thought we'd celebrate with something special today. I am going to talk you through a real piece of analysis in Python, from start to finish. And because you now have all the technical skills required, because you've watched all my previous videos, I am going to share with you my take on what a good analysis is, technical considerations aside. Or, in a more clickbaity way, the top 10 things that set apart great analysts from basic analysts. And you don't want to be a basic analyst, do you? So I am not going to talk you through every single aspect of my code. I'm actually going to whiz through most of it. Because today is about the bigger picture. How do I solve a problem using a Python notebook? That being said, I've uploaded my notebook on Kaggle, and you'll find the link in the video description. Putting myself out there for you. Oh, and by the way, we're going to be using Formula 1 data. And the question we'd like to answer, are Formula 1 cars getting faster? And the first great analyst trait that I'd like to share with you is great analysts are structured. Among other things, that means that their analysis is broken down in meaningful steps, and you can leverage some cool Jupyter formatting features for that. When you have a markdown cell, you can use hash keys to create a hierarchy of sections and subsections. It makes your work easier to read by yourself, but also, and most importantly, by others. We are now importing the usual suspects, plus two packages that I haven't presented yet. OS to interact with your operating system, and RE for regular expressions, to find and extract patterns in strings. Using that OS package, I can list all the files in the directory of this Jupyter notebook, so don't look too closely, you can find some pretty personal stuff there. And what I'm interested in are these Formula 1 files. They are the CSVs I got from Kaggle. Using a list comprehension along with a string method, I can isolate these files. And thanks to some regex, I can pull the names just before the CSV. I have a confession to make. I don't know regex. But that's okay. It's actually the second great analyst trait that I want to share with you today. Great analysts don't know everything, but they know how to learn, or at least how to find out. In this case, I know about a great website called regexr. Using the cheat sheet on the side, I've actually managed to build my own regex. The substrings I'm interested in are nicely isolated. Time to start reading the data. My goal here is to build a dictionary of data frames. So I start with an empty dictionary and I populate it with a for loop. Uh-oh. I get an error. Typical analytics scenario. Perfect. Stack Overflow link in position 1. Blah, 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 blah. I had the same error. Solution was to change encoding to Latin 1. Perfect. Let's try it out. It works. Then I like to get familiar with my data by actually seeing what it looks like. So we're going to fast forward here because I'm going to be looking at samples of each data frame. Circuits, great. Constructor results, I see. Constructor lookup. Constructor settings, endpoint, unicorn, drivers, driver settings, app times, pit stops, qualifying, races. Okay, 17. I get 20 rounds. Results. Alright. Status. Status. Results again. Okay, status. Cool. So I know what we're dealing with. Now is a crucial step. A step that often takes the longest in any analysis. Getting your data in the right state. Here I drop and rename a few columns. And here I join everything together in one data frame that I'm calling df. Just a quick check here. Good. The length pre and post join is the same. Nothing crazy happened. And it seems that we have data from 1950 to 2017. So we can start enriching that dataset by adding new columns and fixing some issues along the way. First, let's convert the fastest lap time in seconds. Easy. Let's check the speed column. Makes sense. Aside from this data type, it says object. Ideally, I'd like a float. Let's convert it. Oh no. Another error. That value couldn't be converted to float. Not super surprising because it doesn't look like a float. Let's find out where this is coming from. In that speed column, there's a time value. Let's try and fix this. Here's the problem. If we assume that each driver covers the same distance, there's a linear relationship between time and speed. Therefore, we can apply that factor from another driver to the driver whose speed we are missing. Easy peasy lemon squeezy. That factor is 1.88, and the new corrected speed is here. So now we can convert things safely and create a new speed column in meters per second. We now have the time and the speed, so we can approximate the length of the track. We can move on to a critical step that is often overlooked: sense checking, which is actually the third trait of great analysts. Great analysts regularly check that what they do makes sense. For example, by looking for internal consistency in their findings, or by validating their results against another data source, or simply by using common sense. Let's take an example here. In the previous step, using our crazy logic, we came up with an estimate for the length in meters of each track. So it's fair to ask, are we roughly correct looking at Monza, for example? These are the lengths that we've computed. The values vary because our time and speed values are not super precise. Let's check Google. 5.783. I'm happy with that. We could have checked other things. For instance, the number of points each driver got at the end of the 2017 championship. You can just go to Wikipedia for that. Or what was Ricciardo's fastest time at Monza in 2017. So now that we have the data, we can tackle the question at hand. Are Formula One cars getting faster? What I like to do is save everything in a new data frame. I also like to record the length of that data frame. And since we're interested in speed, let's see how that column is populated. So it seems that quite a lot of values are missing. How does that look if we trend it over time? I see there's a drop around here. Okay, 2004. There's a lot less nulls in the data. So let's exclude all the records prior to that year. We still have some speed nulls remaining, so let's keep cleaning. They account for 5% of the data. Let's group it by Grand Prix. China 2011 is at the top of our list. Looks like we have no speed measurement for that GP. So let's get rid of it. Let's look at the remaining nulls in terms of status. Only one guy seems to have finished the race. All the other ones had some sort of issue. Who's this guy? Daniil Kvyat. Yeah, we're missing all the information about his fastest lap. There's another data frame that we can use though. The lap times data frame. We can look at each of Kvyat's laps, work out which one is the fastest, and calculate the speed. It seems that his fastest lap was lap 52. We have the length of the track. So again, we can calculate speed. 208 kilometers per hour. We can now replace the missing value. Here it is. But hold on a minute. Was it really worth going through all that trouble just to update one driver's speed when we'll be looking at aggregate speed values? Not sure. And this is the time for me to share the fourth great analyst trait. Great analysts are efficient. And in that case, I wasn't. I never said I was a great analyst, by the way. I'm average at best. Great analysts ask themselves, what is the return of my time investment? Bad ape analytics. Moving on. We still have some missing speed values, and as we've touched on before, they all seem to belong to drivers with race issues. These missing speed values represent roughly 4.7% of the remaining data. What I suggest we do is only consider the speed of finishers. Here is how I define them in terms of status. Most of our remaining data falls under that category. And we can get rid of the non-finisher records. Finally, we've eliminated all the speed nulls. Feels great, doesn't it? And overall, we got rid of a very large portion of the data. Cool. We can now aggregate everything at year and country level, and we are taking the median of the fastest lap speed. So we have everything we need to answer the question. Just looking at Australia, the dots show you the speed every year. And you can see this declining trend up until 2014 roughly. I've added a secondary vertical axis that shows you the lap length. The reason I did that is to make sure the track has stayed the same. Because it's not really a fair comparison otherwise. And that's great analyst trait number 5. Great analysts preempt questions and challenges. So this was Australia. It wouldn't be a very big effort to build the same charts for all Grand Prix. It's pretty easy to implement with a for loop like we did before. So let's do it, because this is great analyst trait number 6. Great analysts work in a scalable way. We now have all the Grand Prix. First, it could bring up something interesting. Second, that might be useful later on to me or to another analyst. And third, it looks pretty cool. I can confirm the overall declining speed trend and also see which tracks saw some changes, which Grand Prix got discontinued, and which Grand Prix are new. So let's actually store the countries for which the Grand Prix haven't changed and have consistently occurred between 2004 and 2017. Let's sum everything up. Here I'm answering the question very simply. It actually seems that Formula One cars have been getting slower up until 2014, but that their speed has picked up since. And very important here, I document my source as well as the assumptions that I have made. 1. Only looking at 2004 to 2017 data. 2. Only considering the 5 tracks that haven't changed. And 3. We're excluding drivers who haven't finished the race. And you've guessed it. This is great analyst trait number 7. Great analysts clearly document their sources and assumptions. It provides credibility to their work and also makes it reproducible by someone else. We can now build our final visualization. You can see here that I'm only sharing information that I think is relevant. I'm highlighting the speed at the beginning of the period, 2014 as the slowest year, and then the last observation with a higher speed. And this is great analyst trait number 8. They understand the difference between doing the analysis and presenting it. You don't want to give your audience information they don't need, especially if they are not analysts themselves. So what do we make of this? Why have Formula One cars gone slower? Well, I have to admit that I didn't really know. And that's a problem. And that's why, again, I'm not a great analyst. Great analysts have domain knowledge. Being great at Python is not enough. If you truly understand the area you're analyzing, you're going to be a lot more relevant. And the closing comment that I would make is that there's many other areas we could have looked into. And that's actually the last great analyst trait that I'd like to share with you today. Great analysts are creative. This is not about your stereotypical creativity like scrapbooking. It is about the ability of an analyst to think outside the box, to find new ways to solve problems or new data sources to use. We might have been curious about Finland, how such a small country produces so many great drivers. Or how much does your qualifying performance influence your final position? Or considering constructor performance over the long term. Although Ferrari is not first anymore, it has consistently ranked in the top positions for a long time. Cool. And just to hammer it home, these are my 10 great analyst traits, besides technical skills. They're structured. They don't know everything, but they know how to learn and how to find out. They double-check their results. They're efficient. They preempt questions. They work in a scalable way. They clearly document their sources and assumptions. They understand the difference between doing the analysis and presenting it. They have domain knowledge, and they're creative. Why? Because I think it makes their work more impactful. And in my opinion, this is the purpose of analytics. If you build the greatest model or the coolest visualization, it's basically worthless if no one uses it. I hope you've enjoyed this final video of my Python for Analytics series, and I hope that I'll see you on my other videos. I'm planning a sequel series as well as a machine learning tutorial in Python. And I also hope that you'll forgive me for that clickbaity title. As always, thanks for watching. Like, share, subscribe, hit the notification bell, comment to let me know what you think I would like to see next, and remember, practice makes perfect.